Hi there, welcome back to the TUT class. In today's class, we'll be looking at limits and continuity. Now, for limits, what is limit? Limits, to be defined, we will need a function. That is, for us to define limits, we will need a function. A function, say y equals f of x. So we need a function and we'll need a point. A point, say a. Now, if you've gotten these two, you can relatively define a limit. Now, the limit of a function is the number, say L, that a function reaches as the independent variable of a function reaches a given value or point, say A. Now, this grammar would seem very big. Let me just write the mathematical expression and then expatiate further. Now, what I just said in this English is expressed as this. When the limit of a function f of x as x tends to a equals what? L. Now, L here stands for the result of what I'm going to do at this point. This is the result of what I'm going to do here. This is the limit of a function f of x as this x tends to what? A point a. So the limit of a function is a number that a function reaches, that is L, as the independent variable x reaches a given value or point a. Reaches there means tends to a. So x tends to a, of the limit of a function f of x. The answer is what? L. Okay, as simple as that. Now, types of limits. We have three basic types of limits. The first one is the left hand limit. Second one is the right hand. The third one is what? The common limit. Now, for the left hand limit, we also need a function, f at a point a. The expression of this left hand limit mathematically is what? Limit of f of x as x tends to what? The negative a. Now, when we say x tends to a particular point or an independent variable tends to a particular point, it means I can use this point in the equation, in the function, okay, relatively. I can use this point in the what? In the function. Now, the left hand limit is represented as what? Limit of f of x as x tends to what? Negative a. Now, this means the values of x, x are approaching negative. The values of x are approaching the what? The negative side. Just like on our number line, we have 0, we have negative values, and we have positive values. So those approaching the negative values of my x on my number line is called what? The left hand limit, of a function, if expressed as this. Then for the right hand limit is the limit of a function f of x as x tends to what? Positive a. In which case the values of x, moving to the right side or tending to the positive side of what? My x on the what? Number line. Now, for the common limit, we said our common limit is represented as what? Limit of f of x as x tends to negative a equals limit of f of x as x tends to what? Positive a. Or when the limit of our f of x is such that what? X tends to what? A. So, we can call that what? Common limit. This is like just the equal of what? Negative and positive. Right? So, now we have properties of limit. We have properties of limit. The first property of limit is the formula. Limit as x tends to a of f of x equals to what? L. The second property of limit is the limit as x tends to a of what? F of x plus what? G of x. Now, when we have a common value that we are adding together in limits, what is the result? If I'm giving a limit like this in function, what I'm going to do here is what? To express, I'm going to say the same thing as what? Limit of x as x tends to a, of f of x plus what? Limit of g of x as x tends to a. Now, it relatively means I did what? I splitted this limit for both f of x and what? G of x. Okay, so then for the third property of limit is such that I have the limit of limit as x tends to a, of a constant, say m, multiplying a function f of what? F of x. Now, in this case, this is the same thing as what? M times limit of f of x as what? X tends to what? A. So whenever you have a constant, say 2, 3, minus 4, minus 1 over 7, and so on, multiplying a function of x, it is expressed also as what? M times what? The limit of the function as x tends to that what? That point. Now, when we are done with this video, we'll be looking at questions under limit using all these properties of limit so you can understand them very well. Then number 4 is limit as x tends to a of f of x over what? G of x. This is the division part now. Now this is the same thing as what? The limit of f of x as x tends to a, over or divided by what? Limit of g of x as what? X tends to what? X tends to a. And these are all the properties of limit.